Hey guys, today we'll just be doing another C programming tutorial. We're going to be going over the calloc function. So calloc means contiguous memory allocation. It's similar to malloc, which is just memory allocation. So what it does is it allocates multiple blocks of memory based on the number you choose for n. So it takes two parameters, number of elements and size of elements. So the difference between malloc and calloc is that calloc, pretty much this definition is nowhere to be found. So I was lucky to learn from someone that taught it properly. So if you look online, it just says that calloc initializes. It doesn't even tell you properly. So what really happens is it initializes the indexes to 0, to the value 0, whereas malloc initializes your memory to garbage values first before you fill the values in with what you want. Before you use the memory space, it allocates malloc allocates them to garbage values, random values, whereas calloc allocates them all to 0, and malloc only allocates one block of memory. So it stores everything in one index, because remember, memory is an array of bytes. And calloc allocates the memory to the data to multiple blocks of memory. So if you want 3 for n, that means you want to store 3 values in 3 different blocks of n. So if you want, let's say we want to store int, so we'll go over this in a sec, but if we want to store ints, they're 4 bytes, right? An int has 4 bytes on 64-bit computers, I think, so it's going to be 4 bytes times n, which is going to be 3, so it's going to allocate 12 bytes. So 12 bytes allocated in 3 blocks of 4 bytes, so that should be, so 12 bytes allocated in 3 blocks of memory, each of 4 bytes, so that gives us 12. That's all it does. So we'll just do, I've already typed this out. I actually recorded it, but I realized my recorder wasn't on, so we'll just step through the debugger, same thing that I do every time. So people like that, I guess, because actually a lot of programming videos I see, like tutorials, they never do that. They just write it out and they try to explain it and then it's done. So for me, stepping through the debugger really helps you understand the code, see how the values are moving around in memory as well. I know with C you can't see global variables, so sometimes it's pointless, but we'll try our best. So this is all local, so we should be able to see a lot. So we'll try that. Yeah, so I've set up 3 breakpoints here, so I'll just click the debug icon. So it's a similar example to last time. We'll initialize some values and then we'll comment this out to show that the values got initialized to 0. Then we'll just free the memory space, so same thing. So here you guys can see this is the debugger. It shows the variables and the memory sometimes, so stuff like that. You can see everything, but it's not as good as Java, but the compiler isn't as good as Java. You can't see globals, you can't see array indexes. Sorry, you can't see pointer indexes. Some of the data is missing, so I'll try to show as much as I can. So here we have n. We've declared ni and a star ptr, so we've declared a variable n of type int, a variable I of type int, and a variable which is a int pointer named ptr. Pointer is denoted with a star. If you don't understand pointers, I did a whole series on it in the playlist, so check it out. It's like 10 videos or something like that. I'd recommend watching all of them. So here we'll enter, don't forget to include stdlib. I think you need that to use these functions, calloc, malloc, realloc, and free. So here I'll step over that. So that'll print that to my external console. You can't see it, but it says enter total number of vowels. Then here we'll scan F a value for n, which is going to be the number of values, or the number of blocks of memory that we want to allocate. I'll enter 3. I'll hit enter. Then we're saying, okay, well, we want our pointer, which returns a memory address or memory location. We want that pointer to point to the memory location to an int to an int pointer, because you want to say that, okay, well, we want calloc to allocate to an int. So we're going to cast it to an int pointer. So it returns a pointer to an int, a memory address storing ints, the int data type. That's why it's casted. Then we'll call calloc. Okay, well, then we want n number of elements. In this case, we'll pass in 3 for n. And then we want size of elements, which is, we call the size of function, which just tells us how many bytes an int is. If you're kind of confused of what it is, it just means the size of an int is 4 bytes. So it's going to tell that to the compiler. So the size of int means it knows that an int is 4 bytes. So it's saying, okay, well, we want the size of an int, which is 4 bytes. That's all it's saying. Size of just gives the byte size of each data type. So that's pretty much it. So pointer points to this memory location. That's gonna be casted to an int pointer, and it's gonna allocate multiple blocks of memory. In this case, 3 blocks of memory, all of size 4 bytes. So hopefully that you guys understand. So here we have printf, enter the values. I'll step into this loop. It's going to start at index 0. Then we'll say scanf. So we're going to pass in a value, an int value that's specified by the format specifier. %d, we're going to pass in a value for the index ptr plus I. So remember, ptr starts at array index 0 because a pointer is like an array. So it's going to basically start at the address, because when you just reference ptr without the asterisk, it should just be the address. So it's saying, okay, this is the address, ox 20E39E215T0. I don't know if you guys can see that, but it says I is 0 in this case. Pointer points to this address, hex code ox, then some address. So we're saying, okay, well, we want these this pointer to increment. We want the addresses to increment every time. So we're going up in the array of bytes, because remember, memory is an array of bytes. We're storing these. So pointer is an array basically. We're storing each int beside each other, and every time we increment, it's going to go to the next index and store the value in the next index. So each time it just goes to the right and increments, and they're being stored using locality, so they're beside each other. So hopefully that makes sense. So so I'm going to step over this because it might take you to the built-in function. So here I'm entering a value. We'll do this twice, because the way it's done here is that it's going to print out the pointer value and add 1 to it. So I think they have to be next to each other, the values. So we'll just enter 1000 here. And we'll step in, enter 1001. Step in, and then step over, and then I'll enter 1002. That should be our third iteration. So 0, 1, 2. 2 is less 0, 1, 2. Then on this last iteration it went 3. So So 3 is less than 3 is not less than 3, so this loop was false, it skipped. Now we're here. The vals are sorry I sped through that. We've done that a bunch. I think we've gone over that iteration several times in the starting video, so if you guys are confused about that, maybe just go back and watch them. So here we'll say the vals are, we printed that out to the output. So the vals are, then we're iterating through this loop starting at array index 0, or of index 0. Step in, then we're printing out pointer value at PTR. Okay, so here what's happening is we're printing out the pointer value at the address PTR plus I. So remember, if we reference PTR just like that, it's going to start at array index 0. Then we're saying, okay, we want the address plus I, which is plus, in this case it's 0, right? Because we're starting at array index 0, so we're saying, okay, well, we want to print out the value of, that's the address, sorry, that's the asterisk, so we want the value of, which means a star. We want the value of, then the pointer address, PTR. I think you can use the ampersand here, it probably will do the same thing. So we want the pointer address, PTR, plus I, which is I is going to be 0, so it's just going to print out that value at that address. At address PTR plus 0, so since it's 0, it's not going to change. So we can test that with the ampersand after. So we got 1000, so now we'll step in. Oh, whoops, I think I went over it too fast. Okay, so we were at 1. So we said printf. We want to print the value at PTR pointer. So it starts at array index 0 in this case, the pointer array index 0. Plus I, so in this case I was 1. So we're saying we want the next index over, which should have been like 4 bytes over or something. Then we got our value 1001, separated with a tab. Then now we're going to increment from I equals 1 to I equals 2, and we step in. So we want to print out the pointer value of the pointer address plus 2 in this case, so it's going to shift over 2, which would give us our last value, because the first one was 0, second one was 1 over, third one was 2 over, so this is the third one, so I should print out 1002. So print out 1002 to my output. Again, it's in an external window because there's a glitch in C line right now. So I don't think you can step over as well through these functions in Visual Studio, so that's why I use C line. But basically it doesn't let me print them out. There's a glitch. I can't print them. I can't output the values to the terminal. It's like glitching out, so I have to do it externally. So if you guys want to, just code this yourself and you guys can see the values. If me reading them isn't enough. So then we should be here. This loop should become false because it was the third. I was equal to 3 in this case, so 3 less than 3 is false, so this loop got skipped. Went to this bracket, then now we're here. So now we're just freeing the memory space. I don't think it's going to show any change. It might actually for this, but we'll see. Okay, yeah, so it did free the memory space to a garbage value. So let's see what else we can do here. So let's just see if we can change these values to space them out. a little bit more. So total number of vowels, will enter 3 again. So pointer points, okay, we already went over that. Step over, step over, step over, step over, okay. I'll enter 1005 this time. Step in, step over. Hopefully we have enough memory space for this, so we'll just go 1007. Step in, step over. It should work actually. So we'll go 1009. The vowels are, okay, it should work, okay. So we'll print them out, print them out, print them out. Yeah, it worked. 1005, 1007, 1009. Okay, so that's all. Let's try to do one more thing. Let's change this to the address of. Should have the same effect, hopefully. We've done the difference between them in the pointer videos again, so I'm just testing it out here. Sometimes it's good to just play around with it to see what happens. What's the change and all that helps you learn. So we'll just re-debug it. I'll step over, I'll enter something for N. I'll hit 3 and hit enter. Step over, step over, step over, we'll enter some values. We'll go 1000 again. 1000, step in, step over, 1001. Step in, step over. Did that step over? Yes, it did. Okay, so you can tell because these buttons stopped lighting up. So it's waiting for input. Sometimes you can glitch out if you press it again or enter twice. So I hit enter, stepped in, stepped over. Okay, so let's see. So iteration 0, printf, pointer value at address ptr plus I. Okay, so it actually gave us the address in this case. That we want for I is equal to 0, I is less than ni plus plus, step in. Pointer value at address ptr plus I. Whoops, I stepped over. Oh, sorry, I stepped in. That gave us 3. I think it's giving us garbage values. Okay, so I think if we want to reference the array, just reference it with PTR. Okay, I think I know what's happening. So when we call the address, it's actually giving us the address of PTR, and we're saying, okay, well, we want the address, the value at address of PTR plus I. But the thing is, when these are allocated to the memory space, when we call PTR, like when we call PTR itself, it knows to just print out the indexes next to each other. But if we call the actual address, sometimes there's those gaps, you know, there's like gaps between the memory space, then they fill in those extra values. I forgot what the word is, but if there's one index 1000, address 1000, let's say OX 1000, and we want the next value over, sometimes it's a certain amount of bytes over, so they have to fill in an extra spaces, extra memory spaces. So perhaps when we're printing out, we want I, the next one over, it's not actually giving us anything because we want 4 bytes. So let's try maybe spacing them out by 4. I think it's something to do with that. There's a certain amount of bytes allocated to that int, and the addresses aren't spaced out properly. It's saying, okay, we want this address, but remember each int in this case should be spaced out with 4 bytes, but I don't think we're reaching to the next address. The first one should have printed though, so perhaps it's better just to reference it with PTR.